Hey guys, we're going to take a minute today to review ionic and covalent bonds. These were the types of bonds that we finished talking about right before we went on Christmas break. So the first bond is ionic. Ionic is created between a metal and a nonmetal. So sodium here, Na, this is our metal because it is found to the left of that stair step or that ziggy-zaggy line on the periodic table. Chlorine is our nonmetal. It's from the top right corner of the periodic table. The second important things about ionics are that the electrons are transferred. So here we see that sodium has an electron and he moves and leaves sodium and joins up with chlorine. So this leaves chlorine with a full outside shell, and sodium lost his one valence, which gives him a full outside shell too. In addition, the last hint on this slide is that they are drawn with arrows. So anytime we draw an ionic bond, you will be using arrows to do so. When we draw them, I just kind of did an example for you, but the first step is draw the Lewis dot diagram for each element, draw a circle around the electrons of the metal, and draw an arrow to show where the electron moves. So we're going to try this with magnesium and chlorine. So magnesium, its chemical symbol is Mg, and it's in the second column on the periodic table, so he has 2 valence electrons. Chlorine symbol is Cl. He is in the 17th column on the periodic table, so he has 7 valence electrons. And remember, the ones place gives you the number of valence. So 17, the ones place is a 7. We're going to draw a circle around the first electron at magnesium and draw an arrow to his new home with chlorine. So here we can see that chlorine now has a full outside shell. He's got 2, 4, 6, 7, and now an 8th electron. Magnesium still has to get rid of this other electron over here. So we're going to end up drawing another chlorine because chlorines want 1 valence and this magnesium still has 1 to give up. So we're going to draw our circle around that electron and our arrow to its new location. So before I switch slides, I do want you to take notice of how many of each we have here because I do have to delete them. So here we have 1 magnesium and we have 2 chlorines present to create this bond. Okay, so 1 magnesium and 2 chlorine. So when we write the formula, we have to count the number of each element. We just did that. Write the symbol of the metal first. So down here I'm going to write Mg because that was the metal. Then a subscript to show how many are present. Write the symbol of a nonmetal, Cl, and a subscript to show how many of those are present. But remember, you do not need to write a 1 if there is only 1 present. This chemical symbol tells us we have at least 1 there already. So we had 1 magnesium, I don't need a number here, and we had 2 chlorines. So the chemical symbol or the chemical formula for magnesium and chlorine is MgCl2. Now we have to write the name. So the metal's name does not change at all. I'm just going to simply write down magnesium. The nonmetal's name changes slightly. We write chlorine. And we take the ending and completely cross it off, and we replace it with this IDE. So our full name is magnesium chloride. So magnesium chloride had 1 magnesium and 2 chlorines with 2 circles and 2 arrows. Our chemical symbol or our chemical formula was MgCl2, and now our name is magnesium chloride. So that's ionics. Covalence follows similar characteristics, but instead they are 2 nonmetals. So we end up seeing a lot of these elements over and over again because they're from the top right corner of that periodic table, and there are a lot less of them. Our electrons are shared. This was the joint custody example that we talked about in class, and we drew them with circles, which were then replaced with lines. In order to draw covalent bonds, the first thing we have to do is draw the Lewis dot diagram for each element. Then we draw a circle around the newly paired electrons and replace the circle with a line. Those 3 steps everyone seems to be pretty good with. It's the next step that people tend to forget. You must redraw all of the non-shared electrons around the original symbols. Those electrons do not go anywhere, so we have to consider that they are still present and we have to continue to draw them. So here we're going to try this with oxygen and hydrogen. So first thing I'm going to do is draw a hydrogen with its 1 valence electron, and then an oxygen who is in the 16th column, so he has 6 valence electrons. So that's our first step. Lewis dot diagram, Lewis dot diagram. Now I'm going to circle the newly paired electrons. These electrons are going to become best friends, and they're going to travel around hydrogen, then around oxygen, then hydrogen, then around oxygen. So if you look, hydrogen technically has a full shell now. He only wants 2 valence electrons, and he now has 2. Oxygen has 2, 4, 6 with this guy, 7 valence electrons. So we have to draw a second hydrogen. And we are going to draw our circle to connect them. So that step's pretty easy. Now I'm going to take that step and I'm going to redraw it with lines instead. So we have hydrogen with a line to an oxygen with 1, 2, 3, 4 valence electrons still there with a line to another hydrogen. So notice we have 2 hydrogens here and they are both connected to the oxygen. So our lines have to go from an H to an O. Now before I delete this to move on to the next slide, take note. We have 2 hydrogens and 1 oxygen to create a complete bond. So when we write the formula, we write the symbol of the first nonmetal with a subscript to show how many are present. So I had H as my first nonmetal, and there were 2 of them. Write the symbol of the second nonmetal with a subscript, but remember, you do not have to write a 1 if there was only 1. That letter in itself tells us there was at least 1 oxygen. So our formula for this compound was H2O. Now when we write the name is slightly more difficult. So we do the same thing as we did with the ionics. The first word doesn't change, the second word gets the IDE. But now we have the option of adding a prefix. So down here I'm going to start off. Hydrogen's name does not change. So hydrogen is going to be written as hydrogen. But I'm going to add a little line out front to remind me, or a curve, to remind me that I have to put a prefix there, or I might have to put a prefix there. The second word, the ending changes to IDE. So oxygen, all 4 letters at the end cross off and it becomes oxide. And again, I'm putting a line out front to remind me I might need a prefix. So going back to the first nonmetal, if you only have 1, a prefix is not needed. Well, we had 2, so I'm actually going to put the prefix of di here, dihydrogen. The second nonmetal, we have to have a prefix every single time. So here I'm going to write mono. So our name is dihydrogen monoxide. So we had 2 hydrogens and 1 oxygen. We had a line connecting a hydrogen to an oxygen and another hydrogen. Our chemical symbol was H2O, and our name is now dihydrogen monoxide. That is the chemical name for water. Now, where this is going to start getting a little bit more interesting. In the past, I've had you work on ionics only or covalence only. Starting now, I'm going to have them all mixed up. So you're going to have to determine what you are going to use in order to find out the names and the formulas. So here, what you're going to have to look at is this deciding factor. Is there a metal? If there is, you are using ionic, which uses arrows and no prefixes. If there is not a metal and there are 2 nonmetals, it is covalent, and here you use lines and prefixes. So that was our review. We're going to take a chance and see how this goes, and I'm going to see how well you guys remember this.